I'm going to talk to you a little bit about broken dreams on the desktop. And essentially, our agenda for today, we're going to talk about rotary desktop fabrication. And rotary desktop fabrication is an alternative technology that can't handle some of the structures of 3D printing, the thin walls, and some of the finer details, but is a much cheaper, much faster technology for desktop fabrication, especially if it takes place in the home. So I'm going to talk to you a little bit about this technology, explain it to you today. So the main advantages of RDF is that you don't need any 3D modeling skills. So instead of that, there's a real-time visualization of the object being made, and there's a haptic feedback loop which you can then use to change your model. And you can also even, and this is a new thing, and this is a USP for the technology, you can do error correction on the fly. Now, the design, the surface smoothness, and the fact that objects are food safe are the greatest advantages to this technology when compared to 3D printing. And the fact, of course, that you don't need any kind of 3D modeling or design skill to get started with it. So here you see this woman at the top there. She's using RDF technology. So it's a rotary disc fabrication mechanism. So it's not a subtractive process like a lot of other manufacturing processes. This is an additive process where the clay is put on the rotary disc fabrication tool and is molded. And this is the haptic feedback system. You can see her using this, and she can error correct on the fly. You can see the gentleman here on the bottom is putting a texture on the part. Now with a 3D printed part, if you make a mistake with the texture, you're a goner, right? But with this technology, you can just simply with your hand correct this texture and then reapply this texture. This is a far superior technology, especially with this error correction on the fly. There's a lot of really interesting things going on in RDF. So one of the greatest things, of course, the repo project. Everybody knows that the RepRap project for years has been trying to fabricate a self-replicating 3D printer, thus far unsuccessfully. But it is now possible to make a completely self-replicating pottery wheel, ladies and gentlemen. Self-replicating technology already. So I think we can all agree that pottery wheels will be in schools and homes and businesses all across the world, because they are self-replicating right now, today. You can get Pottery Bot kits for $1,600. You can buy those. And a really exciting development, pottery objects, full-color desktop RDF, ladies and gentlemen. The great thing also is that the USP of this technology is true co-creation. So you can now, together with a customer, really create together. This is a USP of the technology. And it's a truly iterative process, and you can agree all that this is a far superior technology than this clunky 3D printing technology we want to believe in. Now, why did I tell you this? I told you this because you have to understand how this story is being pitched to the media, and how successfully you can package a science and technology story with some buzzwords, and then you can bamboozle a journalist into saying whatever you want them to say. They become sock puppets with technology stories because they don't take the time to really understand them. So the great thing about our technology is it's been pitched primarily through context. So initially there was a really significant investment in PR, which means the context of the New York Times or the Economist or these kind of publications telling you about this technology causes you to soak it up. The same reason I'm here standing in front of you on the stage and you start to think about this RDF thing and you think this sounds kind of interesting because of the context. And I wanted you to experience what it was like also as a consumer coming into contact with this technology. Because you have to understand this context and the fact that it makes a mental image in your head, and part of it is inexplicable to you, but it seems to make sense for you, causes you to cognitively kind of have some issues there and stop your critical thinking capability. And that's why I did this first part. It wasn't like a joke. It was really meant to understand, or to get you to understand, how this story is being pitched, what it's like for a consumer coming into contact with it, and also why consumers exhibit really weird behavior, and journalists also. Like, for example, if I told you I'm a glass blower, and I can make anything out of glass, and I made a glass gun, people would be like, well, so what? Right? If I told you I was really good at making things in plastic and I made a plastic gun, everybody would be like, so what, it'll never work. But if you're told that this technology that makes a mental picture in your head, it seems complicated, but you learn layer by layer, you manufacture things, and you can make anything with this technology. And then somebody says, I 3D printed a gun, then it's like, oh my God, oh wow, wow, that's news, right? So we want these stories to be true. And technology, and this is how you pitch this to journalists, and this is why this has worked, and this is why we've gone on this narrative for the last 2 to 3 years of being able to reach mainstream media, because this story seems to fulfill the technological promise, because we want new things to believe in. We want to believe in magic. There's a problem, because this is this dream that's being sold, and it's a dream that everyone can right now make anything on the desktop using a desktop 3D printer. Everyone can customize everything. And the most succinct way for me to express this is bullshit. This is a complete and utter total lie. And I believe in 3D printing in the future. I believe that it'll have a lot of impact. I believe about 1% of consumers will use this technology very often. But the central core narrative being told right now, also by people selling machines, is right now with a desktop 3D printer you can make anything you want on the desktop. And this is just a lie. So the reality is people are selling ABS plastic for 45 bucks a kilo, which is like hilarious, right? Is the right name for this pricing, right? Don't tell the Mexican drug cartels, they're like, 45 per kilo? Like they will start getting involved in this, and they haven't even learned of the photopolymers, right? Also, it takes too long to design for the technology. It takes too long to learn to 3D model. The software tool chain is still too complex. And the biggest problem really is desktop 3D printers suck, right? They're like, I mean, it's very difficult to understand how much they suck. It would be, in my opinion, damn near impossible for you to go into any store in this country and buy a product that is as low quality, as poorly designed, and with as low uptimes as a desktop 3D printer. The most venal, cheapest factory in China does not have the guts, the gumption, and the balls to put out products that are this low quality. They will not push this stuff out the door. But in this industry, it's you put an old rep wrap in a new box, and then all of a sudden, boom, it's a revolution, right? And meanwhile, these things have incredibly low uptimes. These things have like really poor looking parts. It was worse in the beginning, right? In the beginning of this desktop thing, the Generation 1 machines, it was like buying Sputnik with Russian instructions and parts missing, right? And the second generation machines were better, but the second generation machines seemed to be like, kind of like a hobby for a mechanical / electrical engineer with way too much time on their hands, who's also like had a predilection for masochism, right? You would have these people like, they would work like you'd speak to them privately, and they would work like 150 hours to make the machine, and then wait 4 weeks for another part, and then get another 300 hours of calibration. And then all of a sudden, and this is the thing that surprised me, the two things about the desktop 3D printing revolution that surprised me the most, is one is, these people then went online and then said, ta-da, my first 3D printed part. And not one of them, and I tried to track all these guys' initial posts, not one of them said, oh yeah, by the way, it took me 500 hours, right? Everyone, I call this the 3D printing omerta, right? Everybody's just keeping their mouths shut and about how difficult it is to operate these Generation 2 machines. And the second thing that surprised me the most about this whole revolution is, to me, it is statistically improbable that out of all the live demos of these machines I have seen, that one of these machines has not broken down live on television. It is literally the most luckiest we've ever been. And then especially like these machines have been improving, right? In the first generation machine, right, it was like, what did you do? Did you put some spaghetti, you colored it, and you glued it together? I was like, this is supposed to change the world? Were you going to be kidding me, right? And now the parts are becoming more attractive, they're coming much quicker, and these machines are improving. But there's still an enormous gap between what is being promised to people and what the actual, the state of the technology is. Oh yeah, and by the way, there's some talk about the UFPs being bad for you. The study is really seriously flawed in my opinion. Worry about the hydrogen cyanide. That's the one that's going to get you. And I would advise everyone, if you have a desktop 3D printer that prints ABS, I would definitely only use it under a fume hood. Okay, so these problems are all technical problems. These will be solved eventually. But the other problems are problems of consumer behavior, and these are much more difficult to solve. Now, where's your juicer, right? A lot of people have a juicer, and a lot of people really like fresh orange juice, right? And the only thing you have to do is get this bag of oranges, take it home, you cut one open, you put it in the machine, and then later you clean the machine. And then you can have fresh oranges every day. What do people do? They have their juicer, and I call this the cabinet of broken dreams. In European kitchens, it's above your fridge, right? There's a cabinet above your fridge, and then there's stuff in there that for the perfect life that you never actually use, right? Your juicer is in there collecting dust, as is your bread baking machine. You know, everybody, like, we're hardwired to believe in this kind of like the smell of fresh bread. It's fantastic. And I woke up at a friend's house once, I was like, wow, this is amazing. I'm going to do this forever. The fresh bread every morning. Forget it. You don't. It just goes in the cabinet back there collecting dust. And the other thing is, people will tell you there's this amazing device. You can make anything you want, customize anything you want. And one of the true things that people care about as a customized thing, and they want individualized, one of the best things is clothing. And we have been able for 170 years have machines that will enable us to make anything we want in terms of clothing and customize our own clothing, make it all fit perfectly. And almost nobody does that. Even people who really like sewing like to buy a lot of clothes. And then there's the blank canvas problem, the idea, like as Van Gogh told us, you're looking at this blank canvas, it's staring at you. There's this world of infinite possibility, and you're intimidated by it. And that's why you don't create. That's why you can put people in front of pieces of paper and they don't know what to make. We also have, as adults, everyone's a maker as a kid. We make everything. As we grow up, we care more about what the group thinks. We compare ourselves to others, and we conclude that Mary can draw better than I can, that Van Gogh can draw better than I can, and we feel intimidated. We feel judged about these things. So we are less inclined to make things. There's also the time to design. Oh, honey, you broke your fork? Well, I'll 3D model and print you a new fork. Can we move dinner to about 11:30? All right. And also, we like brands. We like to hide behind the shield of the brand. We like to have like a little horse, a polo player. It's a safe way to say that we are stylish and elegant or wealthy or whatever you want to give off as a signaling effect. Right? These are the things that are going to be happening, and you want that brand. And also, nobody has convincingly been able to explain to me where the actual need and the actual benefit is for the individual consumer with current generation machines to owning one. Right? This is destined to be just a thing that if it could fit in this cupboard above your fridge, it would totally go in there. And there's also problems we're creating. All right? There's people, first off, there's overclaim. It sets unrealistic expectations of users, and I think it's still, like, we're really lucky that this first and second generation users haven't broken their silence. But at one point they will. At one point people will say, well, actually, it's been pretty tough going. Actually, I had to wait another 3 weeks because this part thing in my extruder completely got jammed up, and this didn't work, and that didn't work, and actually I'm spending more time on the machine than actually making stuff with the machine. All right, at one point, these guys are going to break their silence and talk to the media. And this disillusionment by these first users will harm us. So there's also too many hypotheticals, right? There's too much of the stuff where people are like, yeah, I drew a house, and I'd like to 3D print it. And then all the media goes like, the first 3D printed house, right? And the problem with that is we're undermining our own future. We're undermining, like, at one point, somebody's going to actually 3D print a house, which is very complicated. And not possible with current stage technology. And once that person 3D prints the house, the media's going to be like, yeah, so what? That was done like 5 years ago with the guy with like the figure 8 house, or the dudes with the canal house in Amsterdam. I mean, seriously, what's the news? So we're making it harder for people to do actual stuff to get news. And I think the most disappointing thing is in this bioprinting area, a lot of this stuff, you know, and this comes from scientists, a lot of this stuff is like made up, misdirected, and a lot of this I 3D printed X, Y, and Z is not backed up with papers, is not backed up with any kind of real research, and seems to be like a funding request directed at the media. So we can only absorb so much attention, and we should direct this attention as an industry to useful achievements. So we need to tell the muggles the truth. That maybe there is magic, but magic is a little harder than maybe we let on initially. We have to get the right customers that have the right expectations about what the machines can be used for and the right idea of what they can actually do and what skills they will need. We also at one point need to talk about actual 3D printed products right now, as opposed to some dream of the future. And we need to also dream of the future in a consistent way. So there's the internet narrative. Let's compare the internet narrative, right? Nobody said in the beginning of the consumer internet, the internet was amazing, because the internet was not amazing. There was nothing there. It was very boring. What they said was, the internet is this network, a magical technology that will connect us all. It's this network that will connect us all together. And in the future, it will be amazing. And this led to a lot of hype, which we are at right now. Then the media started talking about applications. And they started to focus the discussion on the future of the internet. And this led everyone to build the routers, to build the content, to build the websites, to build all the things to actually make the internet a self-fulfilling prophecy. What we are saying is, right now you can make everything on the desktop, which is patently untrue. And this is a problem. This is the difference between the 3D printing narrative and the internet one. The internet story, it's going to be amazing, folks, and this is what you can do with it now. And look at Amazon, what a great company, and this is going to change the world. This is a much better, much more sustainable way, right? And if we're looking at the stages of the internet development in the consumer mind, in the beginning of the internet, everyone could publish anything on it as long as they learned HTML. A lot of freedom, a lot of time to learn, or relatively a lot of time to learn. And then everyone could publish, but nobody did this, right? Only the specialists did this. The second stage was with blogging tools, right? Everyone could publish, and several million people did this, but still not everyone. Hundreds of millions and billions of people ended up publishing online with the advent of Twitter and Facebook, which made publishing as easy as just typing. And what we're saying, in effect, right now is, yeah, we're in the HTML age, and it's actually as difficult as HTML, but we're telling everyone, yeah, it's like Twitter for stuff, right? And this is a complete problem. And we need to change this narrative. So what do we need to do? We need to 3D print money, not hype. We need to actually say, this is Mary, she's a designer, she makes earrings, and she makes $2K a month. So none of these vague kind of white papers that the AM industry puts out, but actually concrete stuff saying, Company X saved 2 weeks and $1.5 million using this technology. We need to actually look at applications that the media can support, because we've gone too long without a major innovation in 3D printing that is just being sustained by the hype. And at one point, we're going to go skidding down the Gartner hype cycle, and that's, in my opinion, very soon, as long as, if somebody doesn't come out with something actually revolutionary, because they've been living off of all this innovation that's been happening over 15, 20 years for the last 3 years now. So we need to come up with, and we also need to pitch the media stories like the hearing aid story. It's the predominant hearing aid production technology is 3D printing. Over 10 million people are walking around with this stuff, and we really want these people to know that this is an actual mass consumption, mass consumer product. And these kind of examples will sustain media attention, and will sustain investment, and will sustain the actual attention of people into our products and into this industry. So we need to avoid getting broken dreams on the desktop. We need to avoid digging our own grave by continuing to lie to the public about and continuing to set up the public for failure by overestimating these machines and not telling people what you can actually do for them. That was my presentation. I'd really like some questions. Thank you very much for your time. Yeah?
So in the room back there, you've got 3D printers and 3D scanners.
Yeah.
3D scanners don't seem to have the same height, and they're not
Yeah.
making the same claims.
Yeah.
Do you have any comments on that?
So the question was, I don't know if everybody heard it, but the idea is there's also 3D printers and there's 3D scanners, and 3D scanners aren't the same height as 3D printers. And I was asked if I have any comments on that. I mean, personally, for me, the 3D scanner thing is not something, like, why does 3D printing work? Because it's a relevant technology story for you. You can, in your house, make things. And the scanner narrative looks like a subsidiary technology story to this. It's relevant only because this is an input for the 3D printer. So it's like talking about mice, right? yeah, we're going to be on the internet, and there's this thing called the mouse, and then you can make like the internet go, right? It seems like a subsidiary story. So it's about the framing of the technology. And it's very difficult to say, this 3D scanning will change everything, except if you talk about personalized medicine, for example, and there, of course, but then you're looking more at the MRIs and stuff. But that's the reason in my mind.
So do you not feel there is the same opportunity for sort of personal 3D capture in the virtual world rather than in the physical world?
The question was, is there the same opportunity for personal 3D capture in the same world? I think there's a lot of opportunity for 3D capture. I think there's a lot of opportunity for people to customize their own avatars, make their own creations online, and to use 3D capture as a technology. I would put that different to scanning, but that's like scanning using your iPhone, scanning using the Kinect, scanning using regularly available technologies. And this should make that kind of creation much easier, and also the creation of products. So, to me, it's a subsidiary opportunity, but it would allow you to say, I'll put my face on a bowl, or I'll put my clay-made thing on a bowl, or I'll create with my hands like this, and I'll sculpt the device in the living room. And these kind of things are very interesting, and you see a lot of hackers and makers working on that. Yep.
I would like to know about, I mean, you didn't spoke about the education, how the education can benefit from desktop, desktop printing, which is another dark side of the 3D desktop 3D printing thing.
Yeah, so how can education benefit, basically? I mean, I think generally, like, it's seen as a thing for STEM education and STEM people to get involved in kind of this technology education type of stuff. I think there's an opportunity for that. I wouldn't generally, for a class of younger kids, let's say, I wouldn't generally push current generation machines out there. I just think they're too unreliable to want to use in a classroom. Older kids could perhaps make a RepRap type of machine, and for them to get involved in actually making stuff would be very different, because they don't actually, especially youth of today, don't actually do a lot of things with their hands and a lot of tangible stuff. So that to me has a real defined benefit on the tangibility aspect. And also on education, but the biggest aspect to me to giving kids 3D printers is the idea of getting them used to failure and getting them, because with the greatest thing about our technology is that it allows you to fail very, very quickly. And kids are often very afraid of failure and very afraid of being tested, and the testing anxiety and that kind of thing comes into play. And by getting a product and actually trying to make something and seeing it doesn't succeed and then working at it and doing this iterative process, they can just see this as much more as a learning experience, and they can see their actual life as a learning experience rather than it being like a question of fear of being tested.
I enjoyed your presentation, great, and fun. And a question I'm going to ask is about reliability.
Yeah.
Now, I'm a designer maker, and I've got something on exhibition on the plinths outside, which you see coming in. And it's stunningly beautiful, made by 3D printing and coated. It's quite large, it's called Thema 3 Reoccur. This isn't a publicity plug. My question is about reliability. Really, if you're a designer maker, you don't have to have one of these machines. It's a bit like being, I'm drawing the analogy with the marine world, where a ship sails along, you've got the guys, the deck officers and the captain, and you've got the engineers. So really, your issue is kind of with journalism and presentation, possibly reliability. But I mean, that's lovely stuff I've got out there, and nobody's ever said, "Oh, machine's broke." I get that problem.
But how did you make it, though? Did you make it on a desktop machine, or did you send it to a service?
I sent it to a company.
Yeah, but that's exactly my issue. I mean, there's also, like, the issue to me is that as a service type of manufacturing solution, it's totally possible to in a reliable or semi-reliable way, because even industrial printers, I mean, are not as reliable as the normal as many other manufacturing devices. I mean, I've worked at a company. You buy a machine for 300,000 euros, and after a week, it's on fire, right? I mean, this is like not something that you would have with many industrial machines. So they are less reliable there still than many industrial equipment, but still there's more of a reliability thing. But you can also see if you do actual manufacturing, like Phonak doing actual manufacturing, what they'll have is like a whole bunch of these smaller per factories. to kind of absorb any kind of issue and to be much more flexible with the type of materials they use. So the manufacturing is very different than a lot of these things going on. But just generally, machine reliability is, for me, a huge issue to the individual user if you would actually want it to consistently make parts. I've looked at use cases where we wanted to have a particular machine, and then we wanted to, this is a couple of years ago, print 2 things a day with it. And then the conclusion was, yeah, after we tested the thing, it's like, yeah, Bob, take it home, do something with it, because it won't be able to perform to that thing. And my problem really is not per se, I think we'll solve this stuff. Especially if we move away from the gantry architecture, which I don't really like. I think it's a trapeze act kind of way to make your build platform, so I don't really like the architecture. But especially if we move into Delta machines and next generation machines, so the ones appearing next to these ones, I think we'll get more reliable. But my problem is really about how this is being sold, and this will really hurt us in the long run.